Start again. G'day guys. This is a follow-up video to the one I made near Merimbula during the VLF reception from a little country off a little country road. This is a follow-up video to that. This is I'm actually looking at what I recorded on the day, just checking it on my computer at home. It's a bit easier to see signals and that. First thing I noticed is that I've actually I didn't have audio on when I was actually up there doing the recording. I was only just purely looking at the spectrum. Spectrum is that what you see along there. Now at the time I was really only just looking at the spectrum. I wasn't listening to the audio. But anyway, now at home I've actually got it set to AM mode. I've got the filter set to 15 kilohertz bandwidth, which is a lot wider than what a receiver would normally be, but it's just so you can appreciate the and I've worked out what was causing the noise floor to jump up and down continuously. It's purely lightning strikes. There was a lot of lightning strikes obviously in that area at the time. I'll just turn the volume up here and you'll be able to hear the actual lightning strikes. Just change the bandwidth a little bit. As you can hear in AM mode, the lightning strikes are almost continuous. That's each one of those individual crackles is a lightning strike somewhere around the world, and you can see that's what's keeping the noise floor up so high. The noise floor would normally be down at around minus 100 dBm. It's actually sitting at around 75, 70 dBm, minus 70 dBm that is, and it's purely just on all the lightning strikes. All these horizontal yellow and red lines are lightning strikes. The vertical lines represent signals that I was receiving, so all the vertical lines are signals. So anyway, I've managed to identify. I'll just turn the volume down a little bit. I've managed to identify a lot of the signals that I received on the day. I just switched over to continuous wave or CW, and I'm using a filter with a bandwidth of 200 Hertz. So it's a very, very narrow filter. It allows you to listen to individual signals without having to listen to all the noise. We'll start off down the bottom end here, say around about 10, and we'll zoom in. Okay, so now we're basically got a spectrum of from 1 kilohertz to 25 kilohertz. Most of the signals that I'm interested in are in this range here. As you can see, there's a lot of signals down here. I don't know exactly what they are. I have no idea. All these signals below, say 7 kilohertz. There's a lot of them there. I don't really know what they are. I couldn't find any reference to them anywhere. Alright, starting. These are signals that I've already identified in this spectrum here. 11.905, so we'll just go to 11.905. Alright, there's a spectrum there, and you see a little signal popping up on that red line, which is a spectrum. Pops up every now and then. You can see the little red lines it's leaving behind. That is a Russian alpha signal, which comes from Russia, designed to talk to submarines under the sea. The next signal I've identified is 12.649, so we'll go to 12.649. You can actually see the signal there just on the red line. You see it pop up. It kind of does 3 dashes. You'll see that all 3 Amiga transmitters all do the little 3 dashes. You can actually see it quite clearly. It's actually quite a way above. It's about 10, 12, 13 dB above the noise, but you can see the noise floor is very high because of the lightning. Now if there was no lightning, the noise floor would have been down around 100, minus 100, so that signal would have actually been very, very strong. It would have been an excellent signal. At the moment, the noise floor, the lightning, is actually masking the signal, and the only time you can see the signals is when the noise floor actually drops a little bit, and then you can see the signals. Alright, so that one's there. That's also 12.649 is actually a Russian alpha station as well, also in Russia. We'll move on to the next one, which I identified, which was 14905. Okay, I'll turn up the volume a little bit. You can see the signal bouncing there just on the red line. The little yellow circle shows the peak of the signal. Alright, 14905. I don't know what it is, but it sounds like one of the alpha signals, so it's got to be an alpha signal from Russia. It's got exactly the same characteristics. The next signal that I can see there is 14880, so I'm going to go down a little bit. 8. That's also a Russian alpha signal, RSDN 20-F3, 14.880 kilohertz. You can actually see it just there popping up above the noise. You can clearly hear it anyway. Let's move on to 18.2 now, which is this one here. Alright, 18.2 is either in Japan or the USA. There's two signals on the same frequency. I'm going to guess that that one is the Japanese one, 18.2 kilohertz. The next signal here is 19.8, which I've just selected there. You can clearly hear it. You can see how far above the noise that is. It's literally, what have we got there? It's the peak's at minus 50 dB, 22 to 24 dB above the noise, and it's actually a lot more than that when the noise floor actually drops. In other words, if there was no lightning, it would be much higher than that. Excellent strong signal. It's actually peaking at minus 50 dBm, which is quite a strong signal. Now that signal's in Western Australia. It's put out by the US Navy. Again, designed to communicate with submarines under the ocean. 19.9, so we'll just go up by one there. Don't know whether you can see it, but just on the side of that top one there's another little signal there, 19.9. And that one's coming from Japan or the USA. I'm going to guess that it's a Japanese one. Also designed to communicate with submarines under the sea. Next one is at 20 kilohertz exactly, which is just down here. You can see it on the bottom slope of that strong signal. And according to what I could find, that's in Antarctica, although I can't be entirely sure. A lot of these signals come and go, so you can't be exactly sure of what they are. Some of them don't even have call signs, or they broadcast a call sign very rarely. So, but anyway, that one, 20 kilohertz, comes up as being in Antarctica. Next one along is 21.1. And you can hear it there in the background. You can clearly see it there. 21.1 is either in Russia or in China. I'm going to give it to China this time. China's being a bit closer than Russia. What do we got next? 21.750. 750 is a French station. That's that signal there. The only information I got on it is that it's French, from France, but it might be something else, because I say some of these frequencies are quite old and the frequency lists are not always very accurate. But anyway, the only listing I could find on that frequency is a French station, which is in France. Next one is 22.2. 22.2, which is in, what have I done there? 22.2 is in Japan. You can see it's quite a strong signal. It's well above the noise. In fact, it's about 18 dB above the noise. Japanese station designed to communicate with submarines. Next one, 23.4, 23.4. Now, that one's down here. Now that one's listed as either being in Germany or in Hawaii or in Japan. So there's a choice of three. Again, Japan being the closest, I think I would guess that it's the Japanese one. Moving along, we've got 24.1. That's a carrier, and you can see it's got a little bit of modulation on it every now and then. 24.1 is either, well, it is actually in the USA, North Dakota in the United States of America. I don't know exactly what it is, but it's a carrier, but it does have some sort of modulation on it. You can hear it. Alright, the next one, moving along, we've got 40 kilohertz. So what I'm going to do now is bring that back. Put the cursor on 40 kilohertz, and we're going to expand it there a little bit so you can see a bit more clearly what's going on. Alright, 40 kilohertz, that's a Japanese time signal, of course. I'll just click on that, and I'll just move this down to 40. That's an actual time signal that's coming from Japan. You can clearly hear it. It's quite a fair way above the noise at the peaks. It's about 23. It peaks up to about 22, 23 dB above the noise. Now you can see this, as I said before, this noise floor is actually quite high. It would normally be sitting a lot lower, and it wouldn't be jumping up and down, it'd be steady. In which case I would see all these signals far more clearly. Alright, we'll just turn that down. The next thing I found on there was 45 kilohertz, which I can just move the cursor here to it. Now that's just it looks like just purely a carrier. I have no idea what that is or where it is or where it's coming from. No listing at all for it. The next one, I need to move this down a little bit. Okay, and spread that out a bit. So the next one I'm going to look at now is 60 kilohertz, which is this one right here. Again, another Japanese time signal. That's extremely strong, that one.